So the first one, all you had to do was test. This is a test you have to do. And why do we do this test? Anybody remember? Good, to see if it approximates a normal distribution. Good. If it doesn't, we saw yesterday some of those graphs had skew to their curves. We need to make this approximate a normal distribution. So if it doesn't, we stop there and we can't go any further with our binomial distribution. So the first one didn't pass, the second one did. Then you had to correct these. So when you're doing this, say the first number I'm going to start with is 110. Now, rule is you drop the lower one, 0.5. So now it's 109.5. I happen just to leave the same sign that they had. This guy says start at 109, then give me 110. So drop this guy to 108.5. This one says you ended at 109. So up this 0.5. This guy says don't use 109, you end at 108. So up this 0.5. This is called your correction for continuity. And we do a correction for continuity because we have discrete values, which just is one little point. It would be one little point on that graph. So to make this a bar, we correct it for continuity. The rest is going to work the same. The rest is going to work the same. But that's the important step for this. You didn't have to write these out, but I did want you to correct them. Sometimes when you say it out to yourself, you realize it's less than this, so I can only go up to 23, 24. This is as far as I can go. I can't use 25. It helps to write the numbers out. The top part, just add 0.5. If it's a lower end, subtract 0.5. It actually makes sense when you look at the numbers. If it's at least, remember that at least think money in your pocket. If I have at least $10, and you say, can I borrow $10? I say, yeah, I do. I have at least 10. You can borrow 10 and probably more. So it's 110, 111. So drop this 0.5. Now, Lily asked before, what do I do with this greater than sign? I usually tend to put, if it was there, I put it there. Doesn't affect it at all because you'll never hit a 0.5, but it might just remind you of, I took that out of the book, but it might just remind you of the original equation. This one's a little different. If I'm on your number line just at 33 and I need to make a bar out of this, I'm going to have to make this an inequality. It's 1 point. So my rule is the left end, drop at 0.5, the right end, raise at 0.5. And I only have 1 point to work off of. So I have to make it an inequality. So it actually just took that one little line and just made me a little bar. 12, getting more than, that means I can't use 65. It has to be more than 65. So I drop this to 65.5. Again, I'll never hit that one. But for the bar on the normal curve, I need it. And the last two, at most, if that's the most you have, everything's less. So the most I have is 150 and less. Take this guy and up it by 0.5. Getting between, now these are tricky. If it just says between, then they're less than signs. If it says inclusive, then they're less than and equal signs. So be careful of how it's worded. So if it just says between, they're just less than signs. And drop the lower, raise the upper. Good? Can everybody do this? Okay, so now we're going to see why did we go through all this trouble. Okay, so if you kindly open your books to page 278. We're going to do a problem or two. And hopefully wrap this up. Okay. These are the steps you're going to go through. I think I put this on your note page, right? It was on your notes. These are the steps you're going to go through when you're using a binomial probability. You're going to pull out your information, your N, your P, your Q. N is how many in that sample. P, the probability of success. Q, you might have to figure out that's the 1 minus P. Determine if you can use the normal distribution. This is the test you have to do. If it passes the test, this is already the mean. That's calculate your mean, calculate your standard deviation. Remember, this is your variance. Remember, that's your variance. So that's what we're going to do. Okay. Then, after you do that, you write your probability statement, and you correct it for continuity. Take your probability statement and correct it for continuity. Then, the rest is the same as we always did. We go back to your regular z-score formula, because you already made your corrections. You already found your standard deviation based on your sample, so you don't have to divide by the square root of n here. You're just back to a regular z-score formula. You find your area, like normal, and you make your last statement. So the only thing we have to do is test, find our own mean and our standard deviation, correct it for continuity, and then use our z-score. Those are the steps you have to do. So let's walk through one. In a survey of 8 to 18-year-old heavy media users, it kind of was like the one before this, 47% said they get fair or poor grades. You randomly select 45, this is your N, and this is your P. We did this one before just to test it. And you ask whether or not they got poor grades. So what is the probability? Here's my probability statement, that fewer than 20 responded yes. How do I write that statement? Fewer than 20. Okay, just right, that's good for now. Good. So Lily went ahead and corrected it for continuity. So it only can go up to like 19, because doesn't it have to be less than 20? So this is your upper level, upper end. So it's going to be S is less than 19.5. This is the statement we're going to use. Let's make sure our test, we did this earlier, but we're just going to make sure we test. We know it passes because we did this one in a previous example. So your N was 45, your P was 0.47, and your Q was 0.53. And we did this test in an earlier example, so we know that it worked. Now, the rest is like you normally do. Find your mean, find your standard deviation. N times P is what you did here, 45 times 0.47. So your mean was 21.2. And your standard deviation, just take 21.2 and multiply it by 0.53. And take the square root. Don't forget to take the square root. And your square root is 3.4. It's in your book. So they did it for us. Now, I have all the information I need. I know what my mean is. I know where my pieces go. I know where my 20 is. I can sketch if I want to, and do if you like to do a sketch. Or you can just go to your z-score. This is going to use your regular z-score. Make sure you correct it for continuity because that's the X that goes in here, not the 20. The one that goes in here is this guy. So you're going to say 19.5 minus 21.2 over 3.4. This is going to give you your z-score. Now your book, when they show it to you in your book, they put this whole thing underneath. That's our standard deviation. It's just because the rounding should just be done at the end. But if you round this to 1 decimal, and why did I round to 1 decimal on the mean? What's the rule for rounding?
More than the...
Good. 1 more than the X value. So 1 more than the X value puts me, I only need 1 decimal point. Make your standard deviation the same as your mean. Because if you wanted to make your thing here, you'd put your mean in the middle, which is 21.2, and your standard deviations would go up and down. So where is my 19.5? Somewhere over here, and I want it to be less. Is my area going to be greater than 50% or less than 50%? Less than. So make I would really like just a crude sketch like that is fine. Just so that you get perspective on what you're looking up. So your z-score comes out to be negative 0.5. You look it up in your table, and your answer is, so you have about a 31% chance. What is the probability that fewer than 20 will say yes? It's about a 31% probability that fewer than 20 of those 45 will have responded yes. Okay, and you can still use your calc for this.
What's your Q again?
Your Q is 1 minus P. So if your P is 0.47, your Q is 1 minus that. They don't tell you that, you have to find it. Because all your probabilities have to add up to 1. Okay? Now, you can still go to your calc for this. Oh. You can still do your calc. So if you go to your normal CDF and you say, my lower limit is negative 999. My upper limit was, what's that, 19.5. Make sure you use your corrected one. 19.5. My mean is 21.2. You could even put your whole standard, you could even put the multiplication things in here. If you wanted to, I could do this. It will give me a little bit more exact, but I could say 45 times 0.47. Make the calc, work it out. Or just put in your mean, whichever one you prefer to do. Your standard deviation is 3.4. And paste. And it's going to come up with your area. So you can bypass, you still have to correct for continuity, you still have to find your mean and your standard deviation. But you can even let your calculator do that if you're a little on the lazy side. Okay? Because you're back to your regular z-score formula. Does that make sense? All we're doing is correcting this for continuity. And what gives you a hint to do that is you're going to have to find your own mean, you're going to have to find your standard deviation, because the z-score needs your mean for the population, and you don't have one. So you're going to have to get that n times p thing out there. So let's try this one. In a survey of adults in the United States, 34%, there's my P, said they have seen a person using a mobile device walk in front of a moving vehicle without looking. You randomly select 100 adults. There's your N. In the U.S., it's coming from a population. And you ask them whether they have seen a person using a mobile device walk in front of a moving vehicle without looking. What is the probability? Here's what we're asking. That more than 30 respond yes. So first, how do I write this statement more than 30? X is greater than 30. Good. Now, can I use 30? No, I'm going to start with 31. So I take this and I drop it down. So let's correct it. My advice is you correct it right away, because otherwise you forget. So this is the statement we're going to use. Now, no one gave me a mean, no one gave me a standard deviation. I know I have to use my Z formula. So therefore I know I have to find my mean and my standard deviation. So your mean is n times p, and your standard deviation is the square root of n times p times q. When you do that, that should hopefully trigger, oh, I need to test this. I need to make sure this approximates a normal distribution. So then you don't do anything. You say cannot be done. Because if it doesn't make it a normal distribution, this course stops there. If you go on, you'll figure out, like, you remember Chebyshev's theorem when it was not normal? That's the only time we deal with a not normal distribution. The rest we just let it be. You'll learn how to do that if you go on to like statistics 2 and all that other good stuff. So if you take 34% times your n, 100, this gives you 34. So we pass this. So if I pass this, doesn't my 66 have to pass? Right? Doesn't that have to pass because it's greater than 34? Then that has to pass. So we're good. So here's our mean. 34 times 100. And our standard deviation is 34 times 0.66. Take the square root. And it is 4.7. Now, rough sketch. Here's my mean, 34. I want greater than 30. So I'm over here. Is my probability going to be greater than 50% or less than 50%? Greater. If you just give me this much of a sketch, it's helpful. Because when we look that up and you use your table, you're going to get the left-hand side. If you didn't realize you need the right-hand side, by looking at a sketch, it's going to be wrong. Now, we're going to take your z-square formula. What's my x value? That's my n. 30.5. There's my x. Minus 34. Doesn't that give me a negative z-score? Right? Divided by 4.7. And my z-square comes out to be negative 0.74, which is what I anticipated. It would be on the negative side. So if I look up this area is 0.2296, and I say that can't be possible. I need it to be bigger than 50, so what do I have to do? Subtract it from 1. If I subtract it from 1, I get 0.7704. Now, if you think of that as a probability, put it in a percent. What is the probability that more than 30 responded yes? Well, if you kind of take a look at it, 34% said yes. So 30 is less than half. It's about a third anyway. So I'm a pretty high probability that that's going to happen. 77% chance that that will happen. That's what my probability means. Make sense? Yes? Okay, you guys are going to try it. All right. Let's pull out this information for 4, and then you're going to do the other part of it. 58% of adults said that they never wear a helmet when riding a bicycle. You randomly select 200 adults in the United States and you ask them whether they wear a helmet or not when they ride a bicycle. What is the probability that at least 120 adults will say they never wear a helmet? So what's my N? What's my P? $58. What's my Q? Good. So my test, is my test going to pass? Yes, because I'm multiplying by 200. pretty high number. So my test passed. So, what's my probability statement? Greater than what? Greater than or equal to 120. At least means that's the least it could be, and more. At least $120 in my pocket. What do I have? Can you borrow 120? Yep, and probably a little bit more. So now correct this for continuity. So what are you going to start with? What number? So 119.5. So you're going to start with 120. Keep on going. So Lily says, drop this guy. Will I ever hit 119.5? No. Do I need to worry about that? No. So here's a case in point with the equal sign. I tend to keep whatever sign is in the original one. Does it matter? No, because I'm never going to hit that anyway. So it doesn't matter. Your book always goes to without the equal sign, but it doesn't matter there anyway. So either way you want to go with that is fine. Now, I don't want you to do this one. I want you to do the try it for. Use this information, and try it for says, what is the probability that at most 100 people will say they never wore a helmet? So this is the one I want you to do based on that information. I want you to use that information. Don't use this. Use this information down here. And find me this. Trey, you get a probability statement for me? Noah, what's your probability statement? Good. So he originally said at most 100. So he went down. This is an upper, so he made it 100.5. Great. Anybody have a mean for me? 116. Great. Anybody not sure how that came from? N times P. N is 200 times P is 0.58. 116. Anybody got a standard deviation for me? 6.98. So if you were going to put this to one decimal, what would you put this to? 7. 7.0. You can use 6.98, absolutely, that's fine. But if you wanted to round to one decimal, 7. But 6.98 is fine. So now, you've got everything you need. You've got a z-score. X, what is my x? 100.5 minus my mean. And my standard deviation, I'll use 6.98. So Taylor, what'd you get for your z-score? Negative 2.22. Yes, you did. Negative 2.22. Good job. Now, do you want the area to the left or to the right of that? To the left. Your arrow points left, doesn't it? You want the area to the left. When you look it up in your table, it is a small area, and it should be. There's like a 1% chance that at most 100 people will say yes. You asked 200 adults. So, and we did at least 20 before, but now we did at most 100. So that's a big difference. Now, if you use your calculator, and your calculator works great with this, just you have to correct it. So you're going to put your lower limit, negative 999, your upper limit, 100.5, your mean, and if you want to let your calculator do this part, feel free. This is why I need to know what you put in, because if you put in 7, you get a little bit of a different answer. You're in the ballpark, and that's usually what I just look for, but you got to be closer. So if I round this, I pretty much get the same answer. If you use 7, it's just a little bit varied, and that's fine. 7.0 is fine too. Just make sure I see what you put in. Sounds good. Tomorrow, what we're going to do tomorrow is do an in-between one.